In this video, we're going to address Skill 5, Graph Extrapolation. In this video, we're going to learn about the fifth skill, Graph Extrapolation. In this skill, we'll be able to think beyond the graph to make predictions. The first thing we need to answer is, what is extrapolation? What does that word even mean? Well, it means to use background knowledge and trends that you see on a data graph or on a data table to predict past or future data. We also use it to explain patterns that are seen in data sets or graphs. So let's look at this graph. This graph is called Waiting Longer to Tie the Knot. It says Americans are waiting longer to get married than they did decades ago, with larger percentages of both men and women in their 20s and 30s who have yet to say I do. So this is about the age that people are when they get married. So this question asks, what do you predict was the average age of marriage in 1900? Well, we can see on the x-axis of this graph that we only have data that goes till 1950. So it's asking us to predict or to explain what this data might have looked like 50 years in the past. So here are some things I'm going to look at as the viewer of this graph. I'm going to see that from about 1950 to, about 1965, there was almost no change. There was a constant age. And that's about 20 years where the age was constant. So I might say, since the age was constant at about 20 years old, from 1950 to about 1965, I think that if we went back in time, all the way to 1900, there would be no change. And so it would be a constant age, which means that I would predict that the average age of marriage was 20 years old. Something to be very careful of is as we're predicting back in time, we want to make sure that our data or what we're saying makes sense. So perhaps instead of saying 20 years, you looked at this data set in general and you noticed that from 1950 to 2000, there's been a huge increase in our age. So maybe you think that there's been a huge increase in age from 1900 to 1950. Right? And we can see that in 1950 to 2000, which is about 50 years, which is what we're being asked to predict in the past, we can see that the age increased about 5 years. So we could say that since in a 50-year time period, from 1950 to 2000, we had a 5-year increase, maybe from 1900 to 1950, we also had a 5-year increase. That would mean that in 1900, the average age of marriage was 15 years old. And you really need to think, like, both of these are realistic answers, right? It's just how you explain them. So you have to be sure that when you're making graph extrapolations or using data, you explain why you got to your reasoning or why you got to your answer. Really, in this example, both 20 years old and 15 years old would be appropriate. Now, one thing to be careful of is, let's say we extrapolated our data back and it said like 10 years. Remember, a 10-year-old, that's not realistic that 10-year-olds got married, even if the year was 1900. So let's look at the same graph, but ask a different question. Instead of asking us to use the data to go back in time, this question is asking us, what do you predict will be the average age of marriage in 2030? So in a 30-year time span. Well, I'm going to look at the last 30 years here. Here's 1970 and here's 2000. And I noticed that the age went from about 21 years to 25 years in that time period. So in about 30 years, the age increased 4 years total. So I might say 29 years old. And remember, I would need to have a good reason for this. I might say I looked at a 30-year time period, 1970 to 2000, and I saw that the age increased from 21 years to 25 years, which is a 4-year increase. So I think that from 2000 to 2013, which is another 30-year increase, that it will increase by another 4 years. So I did 25 plus 4 and got 29 years old. So once again, let's use the same graph and let's answer this question. Why do you think people are waiting longer to get married? And so in this one, we really have to think, what is our knowledge that we are bringing to this graph? Well, one of the reasons is higher levels of education. More job opportunities. Right? People are living longer, so they don't need to get married as early. All of these are reasons why people might wait longer to get married. Let's look at this graph. This graph shows Christmas trees, the battle between pine and plastic, and it estimates the number of real and fake Christmas trees purchased in the United States each year by millions of trees. So that green bar, the dark green bar, are real Christmas trees in millions of trees, and the bluish bar is fake trees in millions of trees. And this question says, how many fake trees do you think were sold in 2010? Well, here I can notice that from 2015 to 2018, my number of fake Christmas trees, which are this blue, are increasing. So first of all, I am going to say that I know that the number of fake Christmas trees should be higher than 23.6. Because if I keep drawing this line, it looks like that line should be higher than 23.6 million Christmas trees. So I am noticing this difference here. I notice the difference in fake Christmas trees here is 18.6 minus 12.5, which is about 6 million Christmas trees. Between 18.6 and 21.1, that's about 3 million Christmas trees. Between 21.1 and 23, that's about 2 million Christmas trees. So maybe I think, well, about 3 million Christmas trees more each year seems reasonable. So I would say, well, there are 23.6 million in 2018. In 2019, I would have 3 million more. And then in 2020, I would have 3 million more. So I would do 23.6 million plus 3 plus 3. And that would get me 29.6 million. So maybe I would say 29.6 million fake Christmas trees. And I would say, based on this graph, I can see that in the past 3 years, the number of Christmas trees that were fake that were purchased continues to increase. And so I believed that number would continue to increase to 29.6 million fake Christmas trees. I also could say that I know from my background knowledge that fake Christmas trees last longer. So maybe there are more fake Christmas trees being sold because they last longer during the Christmas season. And I've just done this entire slide, and notice that this asked me to do the number of Christmas trees in 2010, not in 2020. Believe it or not, 2020 is the next question. So you are probably sitting here thinking, wow, Miss Matson is super crazy. But we're going to go ahead and say that this was 2020. And on the next slide, we'll do 2010. So I don't have to re-record this whole portion. So since I made a mistake in the previous slide and did 2020 instead of 2010, we're going to change this to 2010. And hopefully, my goodness, I do it right this time. So we notice that overall, these are increasing over time, right? So we would say in 2012, there were 10.9 million Christmas trees. So it makes sense to me that there would be less than 10.9 million fake Christmas trees. But how much less? Well, we can use the information that we had before and say maybe about 3 million less. So I would say that in 2010, perhaps, oops, that doesn't really look like 2010. Let me fix that. I would say perhaps in 2010, there were only 7.9 million fake trees sold. And last but not least, let's think about, why do you think the number of fake Christmas trees purchased is increasing? Well, like I said before, one reason is that fake Christmas trees last longer during the holiday season. So while a real Christmas tree may only last a few weeks, a fake Christmas tree can easily last from November all the way until January. Fake Christmas trees are also less of a fire hazard, and so people who have young children or who want to make sure they don't start fires in their homes accidentally might be more likely to get a fake Christmas tree. Fake Christmas trees also don't involve cutting down a tree, and so people might not want to cut down trees and instead purchase fake Christmas trees. Or, in my example, I am very allergic to Christmas trees, and so I cannot have real Christmas trees in my home. Instead, I need a fake Christmas tree. Hopefully, in this video, you've been able to learn more about graph extrapolation, and you've been able to understand how to make predictions that go beyond the data that is shown in a graph.